Hello and welcome to the video on exponent rules. The first thing you're going to need with this is the graphic organizer. I would like to shout out All Things Algebra from Teachers Pay Teachers for this beautiful tool. You're going to need this. So if you don't have this, pause the video and copy this down into your notebook or print out this file. Great. So now what we're going to do, we're going to go through this bit by bit. So we're going to start with adding and subtracting monomials, the product rule, the power rule, the quotient rule, the negative exponent rule, and the zero exponent rule. We're going to calculate all of these rules algebraically, and then we're going to do it numerically. Okay? Every one of these examples is in the PowerPoint. So the first thing I got to go over is the objectives. So we're going to apply the various exponent rules to algebraic expressions, and we are going to explain the various rules as they are applied to an algebraic expression. So we're just going to go first into vocabulary. The first thing we're going to talk about is a monomial. What is a monomial? And it's an algebraic expression consisting of one term. So that would be x squared. Oops, getting ahead of myself. Need to turn on the pen. I always forget to turn on the pen. A monomial, like x squared. X squared by itself is a monomial because it exists as one term. It could also be like x squared y because we got some multiplication going on there. Or it could be x squared, 3x squared, 2y, 3z to the fourth. Yeah, that's still a monomial, okay, because it's all multiplied together. It would be a trinomial if I had 3 terms and a binomial if I had 2 terms. But we're only worrying about one term. So the exponent is a quantity representing the power to which a given number or expression is to be raised, usually expressed as a raised symbol beside the number or expression. So basically, this guy is an exponent. Sorry for the stray mark. It's the power. It's the degree. Okay? So the first thing we're going to look at is adding and subtracting monomials. When we're adding and subtracting monomials, we're going to combine like terms. So the first thing we're going to look at, this first example is in our first box in our graphic organizer that says 9x squared y minus 10x squared y equals what? We've got x squared y and x squared y. So we have like terms there. So this becomes negative x squared y. Because we take the 9 and we take the 10 and we subtract them. We can do that because the x squared and the y and the x squared and the y are the same. So this one we have subtract 6w from 8w. So let's put that in algebraic terms. So we have 8w minus 6w. And that equals 2w. Because we've got 8 w's and 6 w's. Okay? So we've done combined like terms before. And it's a skill that's not going to go away. It's a skill that's going to follow you all the way up through your senior year. So do that. All right, now we're going to move on to the product rule. So the product rule here, when we have like bases, so what is a base? A base is the bottom here. This is a base. This is the exponent. We can do this if the bases are the same and the exponents are different. So what we're going to do is we're going to add the exponents. So this becomes x a plus b. Now, why does that become x to the a plus b? So we have x. So let's look at Let's look at h squared times h to the 6th. I've got h squared, so that's h times h, right? And then I'm going to multiply it by h to the 6th. And I count up my h's. I have 8 h's there. So that becomes h to the 8th. Okay? That becomes h to the 8th. So now let's look at a little bit harder of a problem. We've got negative 2a squared b times 7 times a to the 3rd b. I want you to pause the video and I want you to think about it for a second. I want you to figure out what you're going to multiply first. All right, so the first thing we're going to multiply is the constants. So we've got negative 2 and 7. That equals negative 14. The next thing we're going to multiply is the a's. So we go a squared times a to the 3rd. That becomes a to the 5th. And then b times b is b squared. Okay? Beautiful. You guys are doing great. I miss your faces. I do. All right. Let's look at the next one, which is the power rule. This is when we have an exponent raised to an exponent. It's like exponentception. All we do is we multiply this. This becomes xab. Okay? Why does that become x times a times b? Well, let's look at the first example. We got x squared times raised to the 3rd power. So that means I have x squared times x squared times x squared. What rule do I have? What do I do when I'm multiplying exponents of like bases? That's right. I add it. So I go x to the 8th, because 2 plus 2 plus 2 is 8. 6. Wow. I'm not editing that out either. X to the 6th. All right. 3 times 2, 6. Pause the video. Try the harder problem. Okay, so let's look at the harder problem. Everything 2m to the 5th is raised to the 2nd power. So let's write that out. So that becomes negative 2m to the 5th times negative 2m to the 5th times m to the 3rd times m to the 3rd. Okay, so we've got negative 2 times negative 2, which is not negative, it's positive 4. Positive 4. And then we count up our m's. We add up our m's. M to the 5th plus m to the 5th. M to the 5th times m to the 5th. That's m to the 10th times m to the 3rd is m to the 13th. Okay? Now, when we're looking at the quotient rule, remember what quotient means. Quotient is division. Power rule, and then we're doing multiplication here. So if we're adding the product rule, if we're adding, okay, if we're adding for the product rule, the quotient rule is we're going to subtract. So that becomes x a minus b. Okay? So, okay, that's not erasing. So let's look at the first problem. It's a fraction. I know they're scary, but it's okay. You got this. All right? So let's first look at the constants and see if there's any common factors. 27 is 9 and 3, or 1 and 27. 42 is 3 and 14, 2 and 21, and 6 and 7. But so we need to reduce these fractions. So I'm going to reduce this by 3. So that leaves me with 7 and 14. That lets me reduce this by 7 to 1/2. That is not 1/2. What did I do wrong? I can't do arithmetic to save my soul, guys. I'm so sorry. And I'm about to put that on YouTube. Look at my confidence go. So we're going to reduce this by 3. So that leaves me with I'm going to reduce this by, I'm going to reduce this by 3, which leaves me with 9. So that's 9 over 14. There we go. That works. So we get 9 over 14. And then we have x to the 5th over x to the 4th. Now let me show you why this is subtraction. 1, 2, 3, 4, 5 over 1, right? So I can divide. I can do the exact same thing that I just did with the 27 and 42. So let's actually look at what I just did with the 27 and 42. I did 3 times 9 over 3 times 14, and I divided the 3's. So that's how I got the 9 and 14. So if we look at these 5x's divided by this 1x, we're going to divide and eliminate those x's. So that leaves me with 9/14 x to the 4th. Okay? So I'm going to let you pause this video. I'm going to count to 10, and then I'm going to resume again. And I want you to try the harder problem in your notebook. Beautiful. All right. So we have y squared, which is y to the 4th, because we multiply these. So y to the 4th over y to the 4th. Y, that is just the same thing over the same thing. So that's going to equal numero uno, number 1. Okay? We have 2 more quick rules that we need to go through. Thank you for sticking with me with this kind of long video. But we have 2 more rules to go through. So let's look at the negative exponent rule. When we have a negative exponent, we just flip it on its head. So we go 1 over x to the a. So if we had 1 over x to the negative a, that would end up equaling x to the a. All right, so let's look at the example. So we have negative 5 times x to the negative 2. So that the negative 5 is going to stay on top. And then x squared is going to slide on below. Okay, Now, with 4/8 over k squared, k to the 5th, that has a lot of skills that we just learned to do that, to do this one. So again, I want you to try it. So I'm going to count to 10 and I'll start the video again in 10 seconds. Ish. Close enough. So I'm going to reduce the 4/8, and that brings me down to 1/2. That is because 4 is 1 times 4, and 8 is 2 times 4. We reduce them. And we've got k squared over k to the 5th. So these go away, and that equals 1/2 k cubed. Now, if we want to be all fancy, we can bring this up and go k to the -3 over 2, and that would be an equivalent expression. Excuse me. Okay. And now we have one more slide. So I'm trying so hard to keep this under 20 minutes. I really think I'm going to do it. So I'm just going to keep going. So we have the 0 exponent rule. When we have x to the 0, when we're not when we're not multiplying it by anything, it equals 1. So 7 times x to the 0 is just 7 times 1, which is 7. Okay, so gonna pause the video, count to 10, do the thing. Awesome, so let's go through it, and I'm gonna whip this one out because we should, at this point, be able to do it a little faster. And if not, that's okay. Feel free to write it out as much as you need. But I'm going to just do it quickly. So we're going to do 4 times 2, that's 8. W over 8 over W over 8. Well, that's just 8 over 8. 8 minus 8 is 0. So that's W to the 0. It equals 1. Okay? And we did it under 20. Actually, we did it under 18. Came in 2 minutes shy of my goal. Awesome. I hope this lesson was helpful. Look out for the worksheet. And I miss your faces.